When we deal with word problems, often the area problems end up being quadratic problems because quadratics are squares and we measure area in squares. So the question says that the area of the flag is 400 centimeters squared, and what are the dimensions if the length is twice the width? So I've expressed the length as 2x and the width is x. And so if area equals length times width, I know that the area of 400 is equal to the length 2x times the width x, and so there's my quadratic equation. Okay, so then solving, this one I don't need to do quadratic formula or anything, I can just solve for x by getting rid of the times, divide both sides by 2, and then square rooting, don't forget the plus minus. However, we can't have a negative length, so we know that one of them is extraneous, so the length is going to be root 200. If you want, you can make that into 10 root 2. That is a simplified radical form. Okay, I'm okay with root 200 though. And then the dimensions are going to be root 200 one way. Actually, I'll write it as 10 root 2. It's going to be 10 root 2 along the short side, and we're going to double that length to 20 root 2 along the other side. So the next problem involves, again, another area problem. It says the side length of Joe's house lot is 3 times the frontage. So here's the front here, and the side length is 3x. So we're going to let x be the frontage and 3x be the depth of the lot. So he buys his neighbor's lot, and so his neighbor's lot is going to be this extra 10 centimeters or 10 meters here, this piece here. So that's extra area that he's going to get from an extra 10 meters of frontage, and this gives him a total area of 1100 meters squared. So again, the question is asked, what's the dimensions of the original lot? So we have this x. If we solve for x, we can find those dimensions. Again, area equals length times width for this rectangle. We've been told the area is 1100, and length and width we can say is the length is going to be 3x and the width is going to be x plus 10. And so there's the length and width. We have our quadratic equation. To solve this, I need to expand this out to get my squared here. I want it in general form to start with, and I'm going to make it equal to 0. Okay, and if this is factorable, we could try factoring this. These numbers look a little bit awkward, so I think I might just go ahead and plug it into the quadratic formula. I suspect this is factorable, but 3 doesn't divide into 1100 very easily. So I'm just going to put this into the quadratic formula. Negative 30 plus minus the square root of 30 squared minus 4. Oops, this is going to be minus 1100. Minus 4 times A times C. The C is negative 1100. Okay, and that's all over 2 times A. Okay, so working this all out, I get negative 30 plus minus the square root of, this works out to be 12 times 1100 is going to give me 13,200, so it's going to be 900 plus 13,200. That works out to be 14,100. Okay, so just double checking that. 12 times 4 times 3 times negative 1100. That's going to give me plus 13,200. Okay, so that's going to be equal to 6. So the x value works out to be negative 30 plus minus 10 root 141. This is not an irrational number, so that wouldn't have been able to be factored anyways. But there's our solution. We can get the decimal value for this solution by just plugging it into our calculator. Negative 30 plus 10 square root 141 divided by 6 gives us 14.79 meters. Or if I do the minus, we get negative 24.79 meters. Okay, this obviously is extraneous, and so x is equal to 14.79, so the dimensions of the lot are going to be 14.79, and then times that by 3, we get 44.37 meters. Okay, so that's going to be the original dimensions of the original lot that he started with.